There we go. All right, hope you enjoyed your snow day. Hope your snow day went well. Enjoyed your extra day off in there. On Monday, we talked about hypothesis testing. Hypothesis testing. Once again, when we're dealing with hypothesis testing, you're now going the full fruition of statistical analysis. Okay, you are looking at trying to prove or disprove a specific value. Okay, prove or disprove a specific value. And when we're dealing with this, you're looking at the null and alternate hypothesis. The alternate hypothesis, what we talked about on Monday, was what you sort of hope is true. And that's usually what the first thing you're going to put down is your alternate hypothesis, because most of the time it's going to be what you hope is true. What you hope is true. And it's all about mu and the standard deviation, or the mu of the population. You have mu is greater than, mu is less than, or mu is not equal to in the alternate hypothesis. So one of those three things is going to be a specific value. The second thing you're going to take a look at is the null hypothesis. And the null hypothesis always deals with the equality. So you're going to have mu. For the first scenario, mu is going to be less than or equal to. The second scenario, mu is greater than or equal to. Or the third scenario, mu would be equal to. Your null and your alternate hypothesis will be the same, will look the same each and every time. Okay, you have to decide whether I'm going to deal with less than, greater than, equal to, not equal to. If we take a look at some other examples here. A researcher wishes to test a claim the average age of lifeguards in Ocean City is greater than 24. And we want to do a mu and alternate hypothesis. So you tend to take a look at what is the hope is true. He wants to test the claim that the average age is greater than the value of 24. So when we talk about mu, what he hopes to be true is more than 24. So we go to the alternate hypothesis first and write an alternate hypothesis. Go ahead and write it down. What do you think it would be? And then go and write the null hypothesis. That's what I have for the null hypothesis. And then the alternate. Okay, that's what I hope is true. Researcher claims the average cost of men's athletic shoes is different than $80. What would be your null and alternate hypothesis here? This is different. We're looking at the word different in there. Trevor, what do you have?
Mu is not equal to E. Wait, yeah, not equal to.
What do you have for the alternate?
Mu is not equal to 80.
And then no?
Mu is equal to 80.
Once again, the thing to always remember is equality will always go with the null hypothesis. Equality will always go with the null hypothesis with this. So we're not equal to or not equal to. And there's key words that occur in all these problems. When you see the word differ in there, those are the better ones because it's just equal to or not equal to. The other ones you have to sort of take a look at what we are dealing with here. Statistical test uses data. Use the data to obtain a sample to make a decision whether the null hypothesis should be rejected. Okay, we are doing a statistical test, and we're going to see if we need to reject the null hypothesis. So we're looking to see whether we should reject the null in all of our tests that we're going to do. Okay, our final statement, just like we did with the confidence interval, we're 90% confident in our population mean between this and this. Our final statement is going to be, we will reject the null hypothesis, or we will fail to reject the null hypothesis. One of two things. We either reject or fail to reject the null hypothesis. I'm sorry, I already covered these. Okay, we have two types of errors. Two types of errors. You have a type 1 error. And these will be multiple choice questions, or not multiple choice, but these will be matching sections in regards to vocab. Type 1 error. You reject the null hypothesis when it is true. You reject the null hypothesis when it is true. That's a type 1 error. We have a type 2 error. We do not reject the null hypothesis when it's false. You have error in each one of these. We can either reject the null when it's actually true, or we fail to reject the null when it is false. If I said the null hypothesis is the defendant is innocent, what would be the alternate hypothesis? Jordan? What would be, you have a defendant is innocent. What would be the alternate hypothesis to the defendant is innocent? What's your other option? You have somebody stand trial. The person can be innocent or what? Guilty. Yes. They can be not innocent or guilty. Not innocent or guilty. One of those two things are going to happen. What would be the type 1 error in this situation? Now, type 1 error is you reject the null hypothesis when it's true. What would happen to a person that's involved in a type 1 error if you were that defendant? You're the defendant and you are now a type 1 error. What has occurred? What has occurred? Type 1 error. Well, type 1 is you reject the null when it's true. What's occurred to this person? What has happened?
Falsely charged guilty.
Yeah, falsely charged guilty. An innocent man goes to jail. or innocent person. They've been convicted. Now, if you go out to the Mansfield Reformatory out there and do a poll out there, I would say 75% of those people out there said, I'm a victim of a type 1 error. I didn't do what they said I did. I've been wrongly accused of doing this. I shouldn't be here. Most people in jail are like that. Type 2 error. What would be the type 2 error here? Type 2. Do not reject the null hypothesis when it's false. Max, what do you think? What do you think? You do not reject this. You don't reject it when it's actually false. Huh? He's guilty, but what's happening to him? Does he go to jail? No. You have a guilty man. You're guilty, but set free. Probably should not say this, because now I'm Google Classroom. And it's just my speculation on this, my pure speculation on this. I don't know anything for fact, but there's a lot of people. There we go. I'm covering myself this way. There's a lot of people that judge the O.J. Simpson case as a type 2 error. You guys are probably too young for O.J. Simpson and the white Bronco. I'm sure you heard stories about it. People said he was guilty and he was set free. And the only reason why? The glove didn't fit on his hand. The glove didn't fit on his hand. The theatrics of a courtroom. I'm going to make sure he drinks and eats a lot of stuff that's going to make his hands swell. The glove didn't fit on it then. People say O.J. Simpson was a type 2 error. But he was set free. He was judged by a jury of his peers. Level of significance. I'm sure hoping I'm doing everything correctly here. You guys are my trial test today. I'm hoping this works out with the Google Classroom and the Google Meet and Screencastify. Level of significance is the maximum probability of committing a type 1 error. That's all that we're going to be dealing with today in this class. When you get into Stats 2, if you get into college into Stats 2, you'll be dealing with a type 2 error. Level of significance, the maximum probability of committing a type 1 error. Probability is symbolized by alpha. That is, the probability of a type 1 error is equal to alpha. And once again, in Stats 1, the only thing that we're going to be dealing with is type 1 errors. Probability of committing a type 2 error, it's a beta value. Bless you. Square it. Probability of committing a type 2 error is a beta value. Officer Riley in there beating up on Mr. Sullivan in there. We got a throwdown going on. Maybe I should put my Screencastify over there. Once again, we will only in this class deal with alpha values. Critical values. And once again, as we go through this, there's a lot of stuff, just like in confidence intervals, just like everything we've done in this class. When you have the initial stuff, it's like, oh my gosh. But once we get to doing problems, once you do one, you're pretty much doing them all. Critical value separates a critical region from non-critical region. We have a critical value that will separate ourselves into regions. We have a critical region and a non-critical region. Your critical values are going to be found on your T-table. So you'll be utilizing your T-table quite a bit. Make sure that stuff's with you. Make sure you take your whole notebook home with you. We have a critical or a rejection region. It's a critical value or a rejection region. The range of values of a test value that indicate there's significant difference and that the null hypothesis should be rejected. You have a critical region, the range of values of a test value. And how we calculate the test value will be very similar to what we've done already. Range of values of the test value that indicate there's significant difference and that the null hypothesis should be rejected. Once again, we're going to do a test value. We're going to see what region we fall into. If we fall into our critical region or rejected region, we reject the null hypothesis that we've already stated. You have a non-critical region, and this is almost exactly the same. The range of values of the test value that indicate there's a difference was probability due to a chance, and that the null hypothesis should not be rejected. So you have two choices here. We're either going to reject the null hypothesis or we're going to fail to reject the null hypothesis. It depends on where our test value falls. We will have a test value. We'll have a bell-shaped curve. We'll have critical values. And we'll place our test value on that bell-shaped curve. We will either fall into a rejection region or a non-rejection region. Once again, you have two choices. We will either reject or fail to reject the null hypothesis. We have a one-tailed test. Indicates a null hypothesis should be rejected when the test value is a critical region on one side of the mean. A one-tailed test. A one-tailed test. When we're on just one side of the mean. The one-tailed test will occur when we have our null hypothesis is greater than or equal to or less than or equal to a value. We have two types of one-tailed tests. It can be a right-tailed test or a left-tailed test. You have a right tail and you have a left-tailed test. What determines this? The easiest way for a right-tailed test is when your alternate hypothesis is mu is greater than some value. The caret points to the right, hence the right-tailed test. For a left-tailed test, left-tailed test will be mu is going to be less than a specific value. This is your alternate hypothesis. Your alternate hypothesis will tell us if it's left tail or right tail. When we have a two-tailed test, when you have a two-tailed test, your test value or your null hypothesis should be rejected when the test value is on either side of the critical regions. This is going to occur when you have mu is equal to or not equal to. That's going to give you your two-tailed test. If we go back to our notes yesterday from Monday, your notes on Monday, we had a bunch of examples on the back side. of our notes. Then we listen to the null and ultimate hypothesis. So we take a look at those. A researcher thinks that expected mothers are using vitamin pills for birth weight, babies will be increased. The average birth weight is 8.6 pounds. 86 pounds, yeah. If we look at the ultimate hypothesis, null hypothesis, would this be a one-tail or two-tail test? One tail or two tail. We're just looking at the notes from Monday, not the homework. One tail or two tail. Just notes. Oh, we have less than and greater than. Andrew, what would it be? Wyckoff. One tail. Okay, would it be right or left? Right. Look at your ultimate hypothesis. So you have one tail right. Look at the second one. One tail or two tail. Look at the null and ultimate hypothesis. Sarah, what do you have? One tail, which direction? Left, because we have less than there. Third one, equal to, not equal to. Callie, what do you have? Huh? Two-tail test. Be a two-tail test. Okay, so that's how you can determine if you have a one-tail or two-tail test. Just look at null and ultimate hypothesis. On Friday, I will have one more day of notes. We'll start dealing with calculations. What I asked you to do for today was just look at your null and or on your worksheet, do your null and ultimate hypothesis. Now, what I want you to do on your worksheet for today or for tomorrow or Friday is write down, is it one tail or two tail test? Is it left or right? On Friday's notes, about the same time here. I'll start at about 8, or I'll start at about 7:45. Okay, about 7:45 on Friday. Sorry, we have school. Okay, we will start dealing with calculations on Friday. Your attendance is required. Once again, I need to check to see if we have attendance. Welcome to school in the remote world. Okay, once again, make sure you turn your camera off. Make sure you turn your microphone off. I don't care what Rover's doing. I don't care if Rover's being bad. I don't care if Rover needs a treat. Questions? We will see everybody on the other side of this. See if I can close this out right. Stop sharing. Stop sharing.